All right, so yesterday we talked about like how to get the system into a matrix, and talked about some of the details of how to talk about a matrix and stuff like that. And then we looked at the basics. We haven't done that. Of how to get a system into a triangular form, and then how that's related to getting a matrix into what's called row echelon form. So today we're actually going to see how to get it into row echelon form. But once it's in row echelon form, how it's then easy to solve the system from there, kind of using a combination of matrices and just equations. And we also talked about the kind of the power of a row like this, where you have two zeros and then a one. Right? That there's no x's, there's no y's, there's only one z, so that one z must be equal to -2, or if it's 0, 1, 0, there's no x's, there's no z's, there's only a y, so that one y must be equal to whatever this is, in the case 5, right? So if we can get the rows to look like that, where it's double 0 and then a 1, then we really like that. So powerful statements. It really shrinks everything down for us. So it's kind of where we're headed with this. Is we want it to be in row echelon form. We'll look at what that looks like. This here really is the same thing we saw a couple of pages ago. We were talking about the operations we could do on an equation and get an equivalent system of equations. This is saying we can do those same operations on a matrix and get an equivalent matrix. That we can switch the rows of a matrix. So if I want to take row 1 and turn it into row 3, and row 3 would then go up to row 1. That's okay to do. We can also just multiply a row by any non-zero number. So again, we can't do by 0 because that would just wipe out the row, which is not okay to do. Or we can add some multiple of one row to another row, which is just what we did in the elimination method. Right? We want to take, so we should be pretty used to that. So this is really going to look very similar to what we did here. Where was that? It's here. It's going to look very similar to what we did here, but instead of being systems of equations, it's just going to be with a matrix. So all the notation and stuff will stay the same. But we start off with just some examples of this. So what we want to get down to, again, is that row echelon form, which would mean that the top left number should be a 1. Okay. So looking at what we have, we notice, well, the second number on the left is a 1. We don't really want a 1 there. We want a 0 there. So that 1 isn't doing us any good there. So if we took that 1 and we moved up here, it would be helpful. So what they're saying is, why don't we just take row 1 and row 2 and switch them? Because we want the 1 to be in the top row, not in the second row. And so, here they like to write it on the top like this. I really like to put stuff next to the thing I'm doing it next to. Just kind of a personal choice. It's notation. So I'm saying this is going to be my new row 2, and this is going to be my new row 1. And I'm just kind of drawing a little double arrow between them. It's kind of hard to see, though. But that's all that is. So I'm just switching row 1 and row 2. Okay. And always, I would tell you guys that whenever you're doing something like this, an operation, think about the stuff you're not manipulating and write that first. So I'm not manipulating row 3. So that's actually the first thing I'm going to write is what row 3 is. So, and always being really careful about watching for transfer errors. So that's 4, -2, -7, then our augment bar, and then the 8. And triple check that, make sure it's the same. Okay? Now I want to take this first row, and I want to get it here in the second row. So I'm switching that over. So that becomes 3, 1, -2, 10. And then take that second row, and that should become my new first row. It should be 1, -7, 1, 5. Basically just saying it's okay to do that. Right? That it helped us meet a goal, which was to get a 1 up here. So, okay. That is okay to do. So what's another way, so different matrix, right? What's another way we could try to meet that goal, right? We want a 1 up here. All right, so there's no 1s just to switch out for it. So what could I do instead? Well, if I could turn that 2 into a 1 pretty easily,
by just multiplying by a half, or I could just divide it by 2. Multiplication by a half and division by 2 are the same thing. So if I just want to take half of row 1, and that's my new row 1, that's okay to do. As long as I do that to everything in row 1. Just be consistent. And I like to write it next to what I'm doing instead of like up above it. But because I'm only messing with row 1, I'm not messing with row 3, so I'm going to write row 3 first. 3, 5, 4, -2. I'm not messing with row 2, and using your finger to help you keep track of numbers so you don't make a transfer error. Really helpful. You're talking to yourself, 5, 1, 2, 5, 1, 2, 7, 7. Now I want to take half of each of these numbers, right? So half of 2 is 1, and half of 8 is 4. And half of -6 is -3. And then half of -4 is -2. So there's my new row 1. But that helped me achieve a goal, which was to get that top left number to be 1. Yeah? So a different way of getting a 1 up there. And this last kind of little partial example is, we can see that some of the work has already been done, that we have 1, 0, 0. Right? And so again, what we want is 1, 0, 0, and then another 0. And that triangle of zeros down there in the bottom left corner. So we have the 1, 0, 0, which need this to be a 0. Okay? So how can I turn that into a 0? Is there a 0 I can flip down in its spot? Right? We don't have any other zeros to move down. Okay? So I can't do that. Can I multiply this -10 by something to get 0? Well, sure, I can multiply it by 0, but we're not allowed to multiply by 0. Can't do that. And so that leaves us really with one option, right? What can I add to it to get it to be 0? Okay. It should be pretty obvious that the 5 is going to be your best bet here, right? Because if I could multiply that by 2 and then add it to 10, -10, I would get 0. So that's what they're saying here. That's why they're saying 2 times R2 plus R3. I'm going to multiply this by 2 and then add it to this. Again, I like to write it next to that. That'll give me my new R3, my new row 3. But you guys make sure you understand, like, we are only actually manipulating row 3. We're saying we're going to multiply row 2 by 2, but we're not actually changing row 2. We're just using those different numbers to manipulate row 3. So when I say, always write the stuff that you're not messing with first, we're only actually messing with row 3. So I'm going to bring row 1 over. So 1, -4, 0, 2. And bring row 2 over, 0, 5, -3, 1. This way, because I've done that, the only spot I have left is row 3. This is the only numbers I can put in here is going to be row 3. I'm not accidentally going to mess with row 2. Okay. So I kind of mentioned this to you guys yesterday, like, you need to find a space to do this work now. We need to do 2 times row 2. So where are we going to write that? Okay. So all these numbers here need to get multiplied by 2. I generally try to do it as close to the other thing I'm going to add it to as possible. So I'm going to put those numbers down here so that I can add them easily. Okay. So I just need to make sure that I don't grab the wrong number though, right? So it's 2 times this, right, which is 2. And you really don't want to circle stuff like this, because if you make a mistake, then you have to go back and try to read through your markings and stuff like that. It's a pain. So I'm circling it just so you guys can see it, but you really shouldn't be doing that. So of course 2 times 0 is 2, and then 2 times 5 would be 10, and then 2 times -3 -6, and 2 times 1 would be 2. What happened in chat? Nope, 2 times 0 is not 2. Good Lord. Thank you. 2 times 0 is 0. Friday. So now I need to do that addition.
So 0 plus 0, 0. Negative 10 plus 10, 0. 3 plus negative 6, negative 3. 4 plus 2 would be 6. So we've moved, right? We actually have the triangle of zeros now, right? We've made that happen. So in order to be done with this, we'd have to be able to find a way to turn this into a 1 and turn this into a 1. So there'd be a couple more steps in finishing this problem, but you can see that we've got the 3 zeros here. So we're really close to figuring out what C is now. So that's kind of the idea, the way we'll be using these row operations to get to that goal of row echelon form. Okay? I'm going to touch very lightly on this. This is not something that we're going to see a lot, so I'm not going to show you the whole thing here. But this deals with dependent inconsistent systems, which are just basically, when you think back what we did like last week at this time, like we were doing the 2 variable systems, you can end up with no solution sometimes, you can end up with infinite solutions sometimes, like when the lines don't cross or the lines are always on top of each other. It's the same thing here. We can end up with 3 lines that don't cross, or 2 lines that cross and then the third one doesn't cross them, or we could end up with 3 lines that are just on top of each other, right? So those are still options with 3 lines. And what it comes down to is seeing that this right here, right, this row right here, well, let me tell you this whole thing. So with this first row, right, 1x, no y's, no z's, equals 1, that actually says x equals 1. No x's value there. And in the second row, no x's, no z's, just 1 y, and that's 2. So we know x and we know y. Then we go to the third row, and it's 0 x's and 0 y's and 0 z's, which is 0. It's not z, there's nothing over there. 0 equals 3, which is, of course, not true, right? And so this would be a no solution system. So in a matrix, how does no solutions pop up? You end up with a row of zeros that equals something that's not 0. That's not okay. So it doesn't matter where that row is. It doesn't have to be the bottom row. It could be the middle row, 0, 0, 0 equals 14, right? It doesn't matter which row it is. You have 3 zeros and then a number over here. That's a no solution system. So that would be an inconsistent system, which just means that there's no solutions. Okay. So when all the variables cancel out, you're left with this number equals 0, not okay. Second matrix here, looking at that top row, we have 1x, so x. We have 2y, so plus 2y, plus 3 z's equals 4. And then the second row tells us that 1y plus 2 z's equals 3. And the third row tells us that 0 x's and 0 y's and 0 z's, so 0 equals 0, which is a true statement. 0 is always equal to 0. But we don't have a particular value of z. So what we should end up doing is writing x and y in terms of z. We're not going to do that just because we won't really see this in what we're doing. If you guys were actually in like the 101 class, you would delve into this part a little bit deeper, but I really don't want to mess with it. And since I'm the only person that teaches this class, I get to make that decision. So I'd rather focus on something else in the time we have. So, but there would be a little bit more here that we would cover if we had just more time to talk about it. But so I'm skipping over this part of how to write the variables in terms of the other variable. But this would just end up being an infinite solution system. That's what it would look like. So when you have that whole row of zeros, it tells you that there are infinite solutions to that problem. And that would be a dependent system. It would depend on what z is. So basically, you would throw z values at it, and it would spit out x's and y's, and you'd have a whole bunch of answers. So that's that, but we really won't see that anymore. we'll be looking at ones that have just one answer. So I'd rather just go look at those instead. But anything with like the row operations there that's like really not making sense, like how it happened. I know the why certainly won't be there right now, like why we're doing that. But anything about the how I did that, you're not okay with? All right, so let's go practice this. All right. Let's go see how we can take this whole system of equations, rewrite it as a matrix, use our matrix operations to solve it. Okay. Especially as we're doing this the first time, it won't seem like this really saves us any work. And really using a matrix to solve a 3x3 system really generally isn't any easier. It's when you take this and go to like a 4 equations with 4 variables and 5 equations with 5 variables and so on and so forth. That's when the time savings comes up. But the math there is so much more complex. We really don't want to get into it. So we're kind of maxing out at 3x3. So it won't seem, especially as you're learning it, like it won't seem like this is a ton easier than what we just did the other day. But again, matrices are really best suited for very, very large systems, which is not something we were doing. So we're just kind of touching on this, saying, hey, this is how it works. And you would just expand these ideas to get to those really big systems. We're just not going to do that. So yeah, sorry, it might seem like, well, it's not really all that helpful, but it's just kind of skimming the surface of this idea. So okay, so the first thing we need to do is take this system and rewrite it as a matrix. Okay, doesn't matter if it's A, B, C, or X, Y, Z, right? It's just keep things in alphabetical order as you rewrite it as a matrix. So I'm going to grab the coefficients off that first row. So 2 and then 3 and then -2. And your augment bar for the equal sign and then -8. Okay? And double, triple check, because if you make a mistake right now, everything after this is going to be screwed up. Okay? So watch all those signs, all that stuff. And then I've got 1 and -1 and 2 and then 25. And then the last row, 4, 6, -1, -7. Okay. You've got to make sure you're not rushing, because that's going to create transfer errors, and those are going to be the most frustrating thing when you're supposed to write 1 and you wrote -1, or you're supposed to write 2, but then you grab the number that was right below it. Okay, so watch those transfer errors, rushing issues. So where do we want to take this? What do we want this? How do we know when we're done? Okay. We're going to get into row echelon form, which is going to look like a diagonal row of 1s. Little cluster of 0s in the bottom left corner. And then these other entries, other elements, can just be any number that they are. And then on the other side of our augment bar again, and these will be values that we won't worry about, like they'll just take care of themselves. But we're trying to make sure that we have that diagonal row of 1s and that cluster of 0s. So our goal is to make it look like this. Okay. We should always start in that top left corner. We're going to work our way down that left column. And we're going to make our way across that bottom row, and then we'll work back up to that one. So the path we're going to follow is this. This is generally the easiest path to do. Always trying to find the easiest way through it. It's generally the way we'll do that. Okay? Down the first column, across the bottom row, and back up. So we need to start here and say, I want that to be a 1. Right? Guys, lots of times you have choices, and sometimes you get kind of pigeonholed into one, only be able to do one thing. But in the first step, you usually have lots of ways we can deal with this. So remember, the first thing we can do, right? First operation is interchange rows. Can I switch a row into that row's spot that already has a 1? Right? We already see the second row has a 1 in it. Right? There's a 1 right there. The second row doesn't need a 1. The second row needs a 0. So that 1 isn't doing that row any good. But it would be helpful up here. So we're switching that row, very viable option. Okay? Second thing we do is multiply a row by a constant. Is there something I can multiply 2 by to get 1? Sure. Multiply 2 by a half to get 1. I can multiply that by half, I can multiply that by half, multiply that by half, multiply that by half. And for most part, that's pretty easy, right? Half of 8 is easy, half of 2 is easy. I don't really like half of 3. It's there. I really would like to avoid decimals if I can. Okay? I don't really want to multiply by a half. It's possible, but don't really want to. Okay? And what else can I do? I can add a row to a row, right? So if I want to get 1, well, if that was a negative 1, then I could add it to this row, and that'd make that a 1. So I could change everything here, signs. I could change the signs on that really easily. Then I could add that whole row to this row, and that would become a 1. So I've got 2 pretty easy things to do to get 1. So then it becomes down to choice, like, well, which one of those would we rather do? It's all choice. Okay? So do we want to switch rows, or do we want to multiply this row by -1 and then add it to that row? Maddie says switch. I mean, switching, yeah, is generally the easy thing. If you can switch, switching is the easiest thing. So let's just switch row 2 and row 1, and to get that 1 up in the top left. We can reorder the rows, and that doesn't change the way the equations work. So again, the way I like to write that, this is going to become my new row 2, this is going to become my new row 1, and I just draw a little arrow between them. Okay? And the text kind of wrote it at the top. Kind of figure out where you want to write stuff for you. Makes more sense next to things than me. But what are we not messing with? I should always focus on what I'm not messing with first. I'm not messing with row 3. I make sure I put row 3 over without changing anything. 4, 6, -1, and then -7. Double, triple check that all those numbers came across the right way. You get really annoyed with yourself if you keep messing that up. Okay? I need my new row 2. So I'm going to make sure I grab row 1, get that written over there correctly. That's 2, 3, -2, -8. And I need my new row 1. It's my old row 2. Make sure I get that written over there correctly, which is 1, -1, 2, 5. So first goal met. Right? We got a 1 in the top left corner. Okay. Then we're going to go down this column. The next thing we need to try to do is get 0 in the second spot. Okay. So how can we turn that into a 0? So what are our options, right? Can we switch rows? Do I have a 0 that's not doing any good anywhere else to move there? No. No switching. Can I multiply by something to get 0? Well, 2 times 0 is 0. But I'm not allowed to multiply by 0. Can't do that. So looks like we're only stuck at one choice, right? We're going to have to find some way to combine rows to get that to go away. Well, turning that into a -2 isn't the best thing. It's possible, it's not the best thing. But turning that into a -2 is going to be easier. So I'm going to multiply this top row by -2. I'm going to add it to that row. So R1 times -2 plus R2. That's my plan. -2 times R1 plus R2 will be my new R2. And I'm going to have to bring that down and around, so get back on the page here. Please don't work like this. I've had students in the past do that, and it's so hard to follow. Get back to the left side of the paper. So I'm not messing with row 1. So 1, -1, 2, 25. That needs to come down. And then 4, 6, -1, -7 from row 3 needs to come down. So notice that I've only left row 2 open. So when I when I do that math, all those numbers can only go there. Okay? Always bring those things you're not changing down first. Now I'll go back over here and do the math that I need to do. So I need to decide where I'm going to write this. I'm going to write it down here, write it up here. I need to add it to this. It doesn't really seem particularly helpful either way. So I'm just going to go ahead and put it up here since it's next to row 1. So I need to make sure I take all of these numbers here and multiply them by -2. And don't grab the wrong number. And you really don't want to circle. I'm circling things because it's easy for you guys to see what I'm doing, but you guys really don't want to do that, because if you make a mistake, you have to go back and like read something and you've got marks all over it. It's not going to be easy to pick out. So you really don't want to do that. Okay? It's easy for me to circle something and then get rid of that circle, but I suggest you guys don't do that. Okay? So 1 times -2, -2, right? And then -1 times -2 is +2, so watch your signs. And then 2 times -2, that's -4. And then 25 times -2, that's -50. Okay. So there I did -2 times row 1. But now I need to add it to this row. These two numbers here need to add. So I need to make sure my eyes are skipping that number in the middle. Again, I don't really want to draw arcs, and I don't want to actually cross that out. I need to make sure that my eyes are skipping it. So you're using your fingers to say, hey, here are the two numbers I'm focusing on. Okay? That's got to just make sure you're putting your eyes in the right spots. Okay? It's not too bad here because I can use my highlighter and not mess up, stuff up where it's irreparable. So those numbers need to add, and these numbers need to add. Okay? So the 2 and the -2 need to add. That's going to go over here now. The 2 and the -2 give me 0. And then the 2 and the 3 here give me 5. And -4 and the -2 give me -6. And the 50 and the 8 give me -58. Okay, so we met our second goal, right? 1, 0. So now we need to move down and get a 0 here. That's our next goal, right? How can we make this 0? So start running through your options, right? Can we switch a row down into this row? Right? Oh, we've got a 0 here, but if I flip-flop these, then I've just undone the 0 here that I needed, so turn into a 4. That's not going to help me, okay? So I don't want to do that. Can I multiply by something? Oh, we can multiply that by 0, but I'm not allowed to multiply by 0. Can't do that. So again, it kind of pigeonholes us into saying, well, how do I get rid of a 4 if all I've got is, I've got to add something to it? Well, I can't add this row to it because there's nothing I can multiply this row by to make that a -4 to cancel that. So this row is kind of useless right now. That just leaves me up here because this has an x value to cancel this x value. So this step is going to essentially be like the last step. I'm going to multiply this row by -4 this time, and then I'm going to add it to this row. So the only way to get this to be a 0 is to take that times -4 and then add it to that. So we don't really have a choice here. That's the only way to do this. So just recognizing that. So -4 times row 1 plus row 3 will give me a new row 3 that won't have an x value there. But I'm not changing row 1, so that row is going to come right over. I'm not changing row 2, so that row is going to come right over. And again, that leaves me with only a certain space to fill with my new row 3 after I manipulate it. So again, now I need to come back and say, okay, where am I going to do that math? I'm supposed to take row 1 times -4, and I need to add to row 3. Well, if I'm going to add, I'd rather be right next to each other, so I'm going to try to do it in this space down here. I'm going to write my new numbers down here so that I can add them easily. So I'm going to take -4 times that top row, but then write those numbers down there. And just -4 times 1. Especially when you guys are doing a negative, make sure you're watching those signs. Negative times a negative is going to be +4. 2 times -4 is -8. And then 25 times -4 is -100. Go back and check your math. Is times -4, times -4, times -4. And then you want to go and do this adding. For -4, give me 0. 6 and 4 give me 10. -1, -8 give me -9. -100 and -7 give me -107. So to see how that got us, further down, right? 1, 0, 0, 1, 0, 0. So our first column is set. We go down the column, then across the row, then back up. So we're gonna go from that 0 to that 0. How do we make that number 0? So that means we're at the 10. Do we have a 0 we can drop down into its spot? Nope. No row switching is going to help. Really, probably after the first, second move, your row switching is probably done for you. You're not going to be able to maneuver anything around without messing up something else you've already done. So row switching is kind of probably out of the picture. Can I multiply by something? You're never going to be able to multiply by anything to get 0. So multiply by 0, 0, we're not allowed to do that. So when you're trying to get zeros, there's really probably only one way to do it. Some sort of combination of rows, just like we've done on the last 2 steps. So how can we get 0 here? What should we do? Okay. We're saying -2 times row 2 plus row 3 will give us that new row 3 that has a 0 where we want it. See if I have enough space to squish this over here. Yeah, I should be able to do it. But I'm not messing with row 1, so it comes across. Not messing with row 2, so it comes across. So I go back and just make sure all those signs are right, because I really don't want to screw up it, because I'm doing a whole bunch of work because I messed up a sign. And double check those, and then come back and say, all right, let's do that multiplication I said I wanted to do. Then you got to decide where you're going to put it. Since I want to add to this row, I want to put it next to that row rather than being up here. Seems silly. Again, that's all just like an eyeball thing. Where do you want it so your eyes can deal with it? But I need to make sure I multiply this row by -2. So I'm going to put those numbers down here. Of course, 2 times, or -2 times 0 is 0. -2 times 5, right? It's -10. -2 times -6 is +12. -2 times -58, +116. And then I want to add. Zero and 0 give me 0. 10 and -10 give me 0. 12 minus 9 is 3. And 116 minus 107 is 9. So there we can see our triangle of zeros, right? Got all those zeros there that we want. So what's left, right? We want this to be a 1. We want that to be a 1. 2 more steps. Okay. Anything so far feeling weird? Again, the big questions are going to be the whys. Like, why am I doing what am I doing? Right? That's where you're just really listening to the thinking that goes behind it. But that stuff will come with practice. Are the hows making sense? The how should be more straightforward. Good. All right, so we need this to be a 1. No 1's the switching spot. Now, if I could turn this into a -2, I could add -2 to 3 pretty easily, and that gives me a 1. But if I do that, that's going to bring this +1 now here, and that's going to bring this -1 now here. I don't want to do that because that's going to mess up my zeros. Okay. So I can't switch anything to a spot. I can't add another row because bringing that 5 down here would be bad also. So what that leaves us is just getting rid of the 3 or turning the 3 into a 1 by multiplying by 1/3 or dividing by 3. Okay. Yeah, right, Victoria. Yeah. So you know what it says is you're supposed to multiply by some non-zero number. So technically what we're supposed to say is we're going to do 1/3 times row 3 will give us our new row 3. Okay? If you'd rather say row 3 divided by 3 will give us our new row 3, I'm not going to gripe at you over that. Okay? It's the same math. Multiplication by the fraction, division by that constant, that integer are going to be the same effect. So, okay. But if this makes more sense to you, then write it that way. Okay. I'm not changing row 1. I'm not changing row 2, so they're going to come down first. 1, -1, 2, 25. Go back and check that against what you wrote. Those 2 seconds that you spend doing that could save you so much time from making stupid mistakes. So don't rush through it and drop some sign, switch some number. That's just going to screw everything up. And I want 1/3 of 0, which of course is 0, 1/3 of 0, which is 0, 1/3 of 3, which is 1, and 1/3 of 9, which is 3. So I got 0, 0, 1, 3 will be my new row. And there we actually know what z is. Right? No x's, no y's. Z, or c, I guess, c is 3. And so we could stop, and once we know what c is, we can start pulling it back in. We could be done at this point. But let's go ahead and talk about how to get it all the way down into row echelon form, which would mean this needs to be a 1. Okay. Again, row switching is pretty much dead at this point. I'm not going to be able to do that without messing something else up. Adding rows is really pretty much, like far as this goes, is not going to work, because if I try to turn this into a -5, and then that becomes a 5, of course, when I add it to this row, it would kill this 0, which I have, which is not going to be any good. All right, I don't want it to be a 5. I want this to be a 1. I don't want it to be a 0, sorry. We could turn that into a -4. That would give us a 1. But that would still just mess this up, because I would be bringing this number down with the 0 and kill my 0. So I don't want to do that. This row is no help, because there's nothing I can multiply this by and then add it to that to make that 1. That's always just going to be 0. So adding rows is no help. So that pretty much only leaves, like we did on the last one, what can we multiply by, or what can we divide by to make that a 1? Well, I can divide by 5, but dividing that by 5, I don't really want to do that. Dividing that by 5, I don't really want to do that either. So there's nothing wrong with decimals. We just really would like to avoid them. And so at this point last night, as I was looking at this, I was like, okay, what did I do wrong? Like, why isn't this working? And so I went back and I followed all my math. I'm like, I didn't make any mistakes, right? Like, what is going on with this problem? So then I just said it, right? Like I just said, we knew what z is. Right? There's z. Z's 3. So I wrote the equations out, and I plugged z in, then I found y, then I found, or I guess that's c. I found c, then I found b, then I found a, and then I went back to the system. I plugged them all in, and they all worked. I'm like, okay, so my math is all right. I've not made a mistake. It's just, I don't know why the notes gave us this problem that we can't actually really get into row echelon form. So I was just like, stupid notes. Okay, so I don't know what's going on here. I don't know why they gave us this problem. There's no nice way to turn that into a 5. Or sorry, to turn that 5 into a 1. Okay. So what I'm going to do is I'm going to show you guys the next step here, which is to go from row echelon form to what's called reduced row echelon form. and we're going to do just a part of that to actually turn that into a 1. Okay? I'm going to take you guys and push you guys just a little bit further than what the notes are saying to do. And then I was texting Ms. Harris last night, who teaches the 101 class. I was like, what's up with this problem? And she's like, well, you just need to do this and this. I was like, yeah, I get that, but that's not what the notes say to do. Why are they making us do that? So I was just kind of annoyed. So we'll do 2 more steps and we'll get it to be a 1. Okay. So, but we're just gonna have to push it a little bit further than what the notes say we're supposed to do. And we're gonna go into what's called reduced row echelon form, almost. We're not gonna get all the way there. So what that looks like, you got those 1s, but then everything else is a 0. Except for whatever those values are. So this is called reduced row echelon form. And if you can get a matrix into reduced row echelon form, you have no solving to do. Because this says, hey, x is equal to blah, and y is equal to blah, and z is equal to blah. Okay, so this is just kind of the next step of this row echelon form and reduced row echelon form. So the path you follow when you do this, again, which is generally the easiest path, like 98% of the time, this is the easiest path. You go down that column, you go across that row, then you go up, over, and then from there, either way, getting one of those zeros is the easiest. They're essentially the same level of difficulty. So again, this purely comes from just doing this over and over again, seeing that this tends to be the easiest path. Just like we did, we run down that row, go get a 1, get a 0, get a 0. Sorry, run down that column. And then turn this into a 0, turn this into a 1. Then you go straight up, get a 0 again, and turn that into a 1. And that's what we're going to do. We're going to do 2 more steps. We're going to turn this to a 0, we're going to turn that to 1. Then we'll stop. We won't go all the way to the end of it. So I know this is a big problem already. I'm going to do 2 more steps, and we'll see. We'll have our C value and we'll have our B value, and we'll solve for A very quickly. So instead of trying to make this a 1, which we saw was difficult, we're going to turn this into a 0. And there's generally only one way to do that. It's going to be some sort of row combination. Right? What can I add to that? It's going to turn that into a 0. So if I try to turn this into a 6, which is not hard, I'm multiplying everything by 3. That's going to turn that into a 3. And then when I add it here, it's going to turn that into a 3, which I don't want to do because I want that 0. I'm protecting that 0. Always be very protective of your zeros or anything that you've already done. Like we worked to make all this happen. You don't want to undo it. So protect that 0. So what else can I do? Well, I can turn that into a 6. That'll stay a 0. That'll stay a 0. So it won't change that. Won't change that. Okay? But that'll turn into a 0. Okay? So that's why I'm using this row, not that row. So row 3 times 6 plus row 2 will be my new row 2. 6 times row 3 plus row 2. Claire, you looks like you wanted to say something. Okay. Did I read you wrong? Did you want to say something? No, I don't know. I saw that. Your interest looked very piqued for a second. Yeah, so I'm not messing with row 1. Comes across. Not messing with row 3. That comes across. I'm going to go back and fix row 2. So I need to multiply row 3 by 6. So I need to multiply all these numbers here by 6. I'm just going to put those down here, and then I'll have to add, across that space. So 6 times 0 is 0, 6 times 0 is 0, 6 times 1 is 6, 6 times 3 is 18. That. All multiplied by 6. Now I need to add across that space. Make sure I'm adding these two, make sure I'm adding these two, make sure I'm adding these two, make sure I'm adding these two. Okay, so skipping that middle row, with my eyes. So of course 0 and 0 is 0, 5 and 0 is 5, 6 and negative 6 gives me that 0 we wanted, and negative 58 and 18 give me 40, or negative 40. Okay. All right. So we got our 0. So next thing we want is a 1 here. Now I can divide by 5 and get this to be a 1 because that's 6 and that's now a factor, a multiple of 5. So I'm going to take 1/5 of R2 or R2 divided by 5, however you want to write that. That'll give me 0, 1, 0, and then 40 divided by 5 is 8, so that's going to be negative 8. So now we have C is 3, and B is negative 8. We can use that top row to find A. We have 1A minus 1B plus 2 C's equals negative or equals 25. And I'm going to plug B and I'm going to plug C in, and we'll solve for A, which is light work. Okay. So B being negative 8, that'd be negative 8, so that's going to be plus 8. And 2 times 3 is 6, so plus 6. So be A plus 14 equals 25. So A is 11. There'd be our order triple.